Hi class, welcome to day 2 of Unit 2. It's called long division and synthetic division. Long division is going to be dividing polynomials using a trick that we kind of did in 4th grade. And then synthetic division is kind of a shortcut method of what we're doing now. And I actually really think you're going to like synthetic division. Okay, so if you remember 4th grade long division, you had something like this. 12 divided into 3, 8, 7, 6, 2, 9. And you only did little pieces at a time. So you said, does 12 go into 3? No. Does 12 go into 38? Yes. So you put a 3 here. You did a 36 and you subtracted. And then you subtracted 38 minus 36. You got 2 and you brought down the 7. And you said, how many times did 12 go into 27? You said 2. Put the 2 above here. 24. You subtracted. You got 3 and you brought down the 6. And then you said, oh, that's 3, that's 36, subtracted, you got 0, you brought down the 2, it doesn't go in there any time, so you put a 0, you brought down the 9, and you said it went in there twice, you got 24, subtracted, and you got this last number of 5, and that was your remainder. So over here, you put down remainder 5, or maybe 5 over 12 as your remainder. Well, it's going to be the same thing here. We're going to set up a long division. It is going to be 4x cubed minus 8x squared plus 2x minus 1. And we're dividing into it 2x plus 1. And how we're going to do this, we're going to be dividing by eliminating one term at a time. So all I care about right now is this 4x cubed. And all I really care about is the 2x. The plus 1 kind of goes along for a free ride. So when I do this division, I'm like, well, what do I have to multiply 2x to get 4x cubed? And I'm thinking, well, it's got to be 2x squared. And I put it above like terms. And then I multiply this by both of these. This has to multiply both. I get 4x cubed plus 2x squared. But this is where I have to be careful. This is very, very important. I'm subtracting, so I make sure I make opposites. So these cancel out, and I get negative 10x squared, and I bring down the next term, plus 2x. Then I say to myself, well, what do I need to get rid of this, multiply 2x by, to get rid of this 10x squared? I say, well, I need a negative 5x. I multiply both of these, I get negative 10x squared minus 5x. Again, I'm going to force opposites. So it's plus this and plus that. The 10x squareds cancel out, and I get 7x, and I bring down the minus 1. And then I say to myself, when I have to multiply 2x to get 7x, I'm going to multiply by 3.5. And when I multiply that, I get 7x plus 3.5. Again, I'm going to force opposites to happen. So it's minus, minus. Those cancel out. I get minus 4.5. And then at the very, very end, I take my remainder here, like I did before. This is my remainder. I put down plus negative 4.5 over, what did I divide by? 2x plus 1. This is high divide polynomials. And my final result is, I'm going to write it out nice and neat, 2x squared minus 5x plus 3.5 plus the fraction of this. This is my final result. And because I wrote it this way, it is called fraction form. I'm getting rid of one term at a time, just like I did in fourth grade. I got rid of like one set of numbers at a time, and I was always bringing down the next, and getting rid of, and having some remainder at the end. Okay, so for the next one, I'm going to do x cubed minus 8 divided by x minus 2. But I had to be careful here because to go from x cubed to minus 8, there are missing terms. So I have to write it like this: x cubed plus 0x squared plus 0x minus 8. And I have to fill in the missing terms. Okay, so all I really care about in the beginning is x cubed and x, and I have to multiply that by x squared. I get x cubed minus 2x squared. And remember, I'm going to force opposites, so this is minus plus, and I get 2x squared plus 0x, and I have to multiply this by x times what? I have to multiply by 2x. I get 2x squared minus 4x. Again, I'm going to force opposites. I get minus plus. Now I have 4x minus 8. I'm going to multiply x times 4, so I'm going to do plus 4 here. And I get 4x minus 8. And when I force opposites, minus plus, I get 0. And I'm very happy. This is the best remainder. If I get a remainder of 0 and it's correct, I'm going to put a smiley face next to it, because that means x minus 2 divided evenly into the problem, or better yet, this means x minus 2 is a factor of the original problem. And whenever you get a remainder of 0, we put a smiley face, and it's correct, I'll give you a plus 1. So when I divided this, I get x squared plus 2x plus 4. Okay, don't forget, you got to fill in the missing terms. Okay, synthetic division uses a different method. Synthetic uses a different method where we don't write out inside the box like we did in fourth grade with all those terms with x's and this and that. We use the root or the 0 of the divisor, which is on the bottom, and just the coefficients from the numerator. It's going to be a shortcut method, and it's all based on multiplication and addition. You know how to multiply and add without using a calculator. So the first thing I have to do is look at the divisor, and the 0 or the root of this is negative 1. And I'm going to put that inside the box. Goes inside the box. And then I'm going to take all these coefficients and write them out. 1, negative 5, positive 3, negative 2. Those are my coefficients. Okay, they stand for x cubed, x squared, x, and the constant term. Now, the first thing I do is I just drop down this 1. Then I'm going to multiply by the number inside the box and put it in the next column. 1 times negative 1 is negative 1. Now I'm going to add. Negative 5 minus 1 is negative 6. Now I'm going to multiply. Negative 6 times negative 1 is positive 6. Now I'm going to add. I get 9. Now I'm going to multiply. 9 times negative 1 is negative 9. And then I finally get negative 11. And this number at the very end is the remainder. Okay? And though this is the way it works, this x here stood for x cubed, x squared, x in the constant term, and when I divide out by this negative 1, I'm really dividing out by x plus 1. So I'm dividing out by an exponent of x, a degree of x. So this really stands for x squared, x, the constant term, the remainder. So if I want to write this in fraction form, it'll be x squared minus 6x plus 9 plus a remainder of negative 11 over the divisor of x plus 1. Okay? So you're dividing up by a layer x. Also, if you want to call the function the numerator, and if I would have plugged in my root of negative 1, f of negative 1 would have equaled negative 1 minus 5 minus 3 minus 2, and I get negative 11. Wow. Plugging in the root into the numerator gives you the remainder that you wanted. And that's the whole idea. It's a shortcut way of doing polynomials. As you can see, I already set up this problem. I did my number inside the box, which is 3, which stands for x minus 3. I have my coefficients, and now I just drop down this 2. 2 times 3 is 6. Add, I get 1 times 3 is 3. Add, I get 10 times 3. I get 30. I add, I get 27. I multiply, I get 81. I add, I get 82. That's my remainder. And now, what did this stand for? Well, this one stood for 2x to the fourth. So this is 2x to the third plus 1x squared plus 10x plus 27 plus a remainder of 82 over the divisor of x minus 3. Synthetic division is so nice. It is really a shortcut on how we do things. Okay, I've set up the next problem. Number inside the box, my coefficients. I drop down the 4. 4 times negative 2 is negative 8. Add, I get 1. Multiply, I get negative 2. Add, I get negative 5. Multiply, I get 10. And I get my remainder of 0. And I'm very happy. This is the best remainder of all time. You do this, you're going to get a plus 1. And that means x, well, that's a terrible x. X plus 2 is a factor, and that means if this was x to the third, then this row is x squared, so my result is 4x squared plus x minus 5 with no remainder. Very nice, very quick and very easy. This next one is a little bit different for a couple of reasons. One, I have a 2x minus 1, not just an x, so my r value is 1/2. That goes inside the box. I drop down the 4. This is 2. Becomes 0. Oh, here's the other thing. The missing term here. X to the fourth, x cubed, x squared did not have a term, so I had to put it in a 0. Minus 6x plus 3. I get 0, I get 0, I get 0, I get 0, I get negative 6, I get negative 3, and look at that. I get my plus 1 bonus. And right now, if I did this, this would be 4x cubed minus 6. But that's not really right, because when I put this inside the box, that really looks like an x minus 1/2 was my factor. I didn't really have that. I had so since we really divide by 2x minus 1, I have to divide this by 2, and we get, my real result is 2x cubed minus 3. That's what I really get. Okay, the next topic is really the list of possible rational zeros. A rational number, a fraction, when I have a problem like 2x cubed minus 4x squared plus x minus 2, I'm looking for possible rational zeros. Well, x cubed can only have 3 zeros at most. But if they were rational numbers, they would have to come from a certain list based on what numbers I have in the problem. So I call it R equals P over Q, where P is the factors of the constant term, which is this last guy, and Q are the factors of the leading term, which is this guy. So for this problem, my R's will equal the P's over Q. Well, the factors of 2 are plus or minus 1 and plus or minus 2 over, well, here's another 2, plus or minus 1 or plus or minus 2. And the way I create this list, I'm going to do all the numerator divided by the first number in the denominator. So when I do this, I get plus or minus 1, plus or minus 2. And then I'm going to do it by that second number in the denominator. So it's going to be 1 divided by 2, or plus or minus a half. And then finally, 2 divided by 2 is plus or minus 1. But I already had plus or minus 1. I don't have to list the same thing again. So this is the possible rational zeros. There are 6 possibilities. Obviously, there's not 6 zeros. There's only 3 of them. But if it's factorable, it has to come from this list. Okay, I'm going to do the next example. Okay, I listed my factors on my numerator and my denominator, because all I care about are these numbers here. And if I do all the numerators divided by the first number, is going to be plus or minus 1, 2, 3, 4, 6, and 12. Now I'm going to do all these numbers in the numerator divided by 2. So it's going to be 1/2. 2 divided by 2 is 1. I already did that. 3 divided by 2. 4 divided by 2. I already did that. That's 2. 6 divided by 2. 12 divided by 2. These are numbers already created in the list. I don't have to put them down again. Then I'm going to do every term in the numerator divided by 3. 1/3, 2/3, 3/3 is already listed. 4/3, 6/3, and 12/3 are already listed. And then everything divided by 6. So there's going to be 1/6, 2/6 is already done, 3/6 is already done, 4/6, 6/6, and 12/6 are already done. I get this whole list of numbers here, and they're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus or minus 24 possibilities. Obviously, there's not 12 zeros. This is next to the fourth problem. There's only 4. But they have to come from this list. And I'll show you what that means on the next page. So the idea here is that I want to create polynomial functions with certain zeros and with a coefficient. Well, if r is a 0 or a root, then x minus r inside parentheses is a factor. So for -1, it is x plus 1. For 3, it's x minus 3. For -5, it's x plus 5. If I multiply this out, this would be x cubed, but I want to have 6x cubed, so I have to put a 6 up front. And that would give me my 6x cubed. The next one is the same idea. It's going to be x minus 2, x minus a half, x plus 2/3, x plus 4. Right now that gives me x to the 4th, and I want 6x to the 4th. I'm not going to put a 6 up front. I'm going to rewrite it because I really don't like these fractions. So this is really 2x minus 1, and this guy is really 3x plus 2. And I still have the x minus 2 and the x plus 4. And now if I multiply it out, I do get 6x to the 4th. So it's taking these zeros, which we kind of did on the previous page, my list of zeros, and creating factors. And I don't like having fractions. So when I see x minus a half, it's really 2x minus 1. So how do I put this all together? I use my synthetic division and this idea of rational zeros, and I figure out how I can factor this big polynomial, 5x cubed minus 7x squared minus 49x plus 51. Here's the graph of it. And right now, I have x-intercepts, or zeros or roots. So when I see this -3, I put -3 inside the box, and this really means the factor x plus 3, and I'm going to use my coefficients here. Let's see. I bring down my 5. I multiply, I get -15. I add, I get -22. I multiply, I get 66. I add, I get 17. I multiply, I get -51. And look at that, I get my 0. Okay? And that's what I want. And now I looked at my next 0, and I see that that number is -1. So I mean 1. So 1 goes in. I don't start from the beginning. I just do a new level. I put 1 inside the box. What does 1 mean? The factor x minus 1. I draw my line. I'm going to bring down my 5. Multiply, I get 5. Add, I get -17. Multiply, I get -17. I get a remainder of 0. And there I go. So what do I have right now? This polynomial was the first factor of x plus 3, the second factor of x minus 1, and this last factor, well, let's see. What color should I pick? Pink. This stood for x cubed. This stood for x squared, so this says x. The last one is 5x minus 17. If I solve this, these are x equals -3, x equals 1, which we knew, and this last one is x equals 17 over 5. And if you notice, all of these zeros or x-intercepts or roots are part of the P over Q list. They have to be inside that list. 17 over 5 is like 3.4. I think this looks like 3.4. In this last example, I did my P's over Q's. I only put the P over Q list to give me an idea of what my factors could be. Obviously, they're not going to be all of them. So I see from the graph, and the graph is a big help, that -2 is a 0, so x plus 2 is a factor. I put -2 inside the box. I got my result. The next one I saw is the unknown one. It's in between. I don't know what it is for sure, but I know that last one is 3. I put 3 inside the box. I wrote out my synthetic. I got my result, and my result is 5x minus 7, which gives me the last x-intercept or root as 7 over 5, which is in the list. So this is a little bit different. It's not really that hard. It's actually quite easy, and I'd be like, why didn't we learn synthetic a lot earlier in life? It helps out with factoring so much. So please ask questions, whether you're in class or on Zoom. I could go through examples again, but it's not that hard, and you will enjoy it. Okay, thank you for watching the video.